With a projected revenue of $40.4 billion in the current year of 2024, augmented and virtual reality are becoming increasingly mainstream. No longer considered just a fad, AR and VR has slowly integrated into society as the reliance on technology increases. The innovative solutions that these realities provide are expected to transform industries through training, engagement, and marketing. Furthermore, developments in the display and haptic technologies of AR and VR will elevate these applications, reducing flaws that disrupt the immersion of users. Through the synthesis of other technologies, the function of AR and VR can be enhanced, improving user adaptation and customization. As AR and VR continue to develop, marketing will grow and expand the exposure and reach of the technologies. These topics will be explored with further depth in this video, with a focus on the implications of AR and VR's technological advancements. First up, let's look at the applications of AR and VR. These technologies are used across a wide range of major industries, though essentially, they are used to enhance technical skills and provide information through visual aid. Within the medical field, augmented and virtual realities are used to guide surgical operations by providing necessary information, and serving as a platform for the exploration of human anatomy in a 3D immersive experience. By helping visualize anatomical structures and surgical trajectories, VR provides simulated surgeries and technical trainings without the need of a physical patient. Spine XR is an immersive game that demonstrates this application, allowing users to refine their spine surgery skills in augmented or virtual reality. Similar uses can also be seen in educational industries where AR and VR are being used as interactive textbooks that bring learning to life. Students can learn about concepts without having to worry about the size constraints or safety concerns of topics like space or the deep sea, enabling them to better engage with complex material or enabling lecturers to customize content for individual learning styles. Dinesh Puni highlights the application of AR and VR in retail for providing visual representations of products to customers. Similar information is given by Bernard Ma in his YouTube video, 10 Best Examples of Augmented and Virtual Reality in Retail, that highlight how IKEA and other companies use AR and VR to provide views of their products within user bodies and environments. Although AR and VR greatly benefit the industries of their applications, they are limited by the sensory technologies that power the immersive experiences. To maintain the suitability of these realities, developments must be made to improve the limitations of their technologies. In summary, AR and VR are being used in major industries to enhance workplace skills and enable interactive learning using the power of controlled environments in the digital world. Within AR and VR, developments in display and haptic technologies are helping create a more immersive and engaging user experience. VR headsets utilize liquid crystal displays, liquid crystal on silicon displays, and digital light processing displays. Similarly, research from Bernard Kress show that AR smart glasses utilize the same technologies. These technologies are currently limited, as studies have shown issues in brightness and response time, hindering the immersive experience of VR and AR, which corroborates with information on the website Designed for Real. The same studies show that LCD and DPO technologies have difficulties in brightness levels and response time, which can reduce the quality of the displays and induce nausea and vertigo in the users. Similarly, TechTarget addresses the same issues within VR, having conducted research that concluded the conflict between visual and vestibular cues significantly contribute to the onset of symptoms, presenting a significant limitation to the application of AR and VR in major industries, as it hinders the user's ability to maintain usage of the technologies. For example, AR-guided surgeries could be heavily impacted, as the discomfort may increase the likelihood of mistakes, putting the lives of patients in danger. Studies have shown that active development in LCD technologies, alongside the implementation of organic light-emitting diode technologies, have been conducted in the recent years, indicating the improvements towards the display limitations. As OLED displays use less power and are thinner and more lightweight, they are ideal for portable devices such as VR headsets. By reducing the weight of AR and VR devices, users can continue to use the technologies for longer periods without experiencing discomfort. This enhances the immersive experience of the users, helping integrate AR and VR technologies as more commonplace industry tools. The integration of AI and machine learning technologies enables AR and VR to create more natural interactions between the user and the digital environment. Whilst AR and VR do provide immersive experiences, they do not have the ability to adapt to the user's behavior and data. By implementing computer vision, powered by AI algorithms, AR and VR systems can recognize and track objects in real time. This drastically improves AR and VR capabilities in detecting the surrounding environment, increasing the range of situations in which the technologies can function. Similarly, the website article Hand-Built Creative explains how, for example, AI can tailor AR and VR educational content to match individual learning styles and paces. Furthermore, it suggests the idea of incorporating AI-powered virtual assistants within AR and VR environments to provide real-time guidance to users, thus enhancing the function of AR and VR when exploring key concepts of a topic. By providing additional assistance beyond teaching material, AR and VR can prompt more growth in users, inclining them to explore and engage more actively with the content. However, it is important to note the limitations of AI, as discussed in the essay by Neil Selwyn, a professor in the Faculty of Education, Monash University, who states, AI technologies are reliant on the quality of the data they are working with. As with any computational process, AI technologies operate through iteration and optimization, the use of approximations and correlations, the production of errors and false matches. So, whilst AI assistants can improve on the learning function of AR and VR, it is however restricted by its bias towards the data they are trained on. To minimize this limitation, several products have been developed to incorporate machine learning alongside AI. The website, Working in Harmony, Augmented Reality and Machine Learning, displays the uses of machine learning in AR and VR through a variety of mobile apps. Google Lens is one example of such app, as it uses AR tracking technology alongside Google's machine learning translation system to scan and translate the text on foreign objects. Machine learning and other neural networks can learn off the data it collects and not only add more interactivity to AR scenes, but further enrich the user's experience. Through this synthesis of technologies, AI can enhance AR and VR to extensively customize to their users, promoting higher levels of user engagement and creating more natural experiences for the users. AR and VR are expected to grow in user size and see an increase in market value in the near future. However, as the following statistics are theoretical, it cannot be said that one source is correct whilst the other is wrong. Instead, the value should be used as a guide indicating the predicted growth of AR and VR. Statistics from the website Statista show that the revenue of the AR and VR market is projected to generate $62 billion by 2029. Contrastingly, the website Prescient and Strategic Intelligence estimates a 2030 forecast of $210 billion. Many venture firms have begun investing in the technology, suggesting AR and VR's potential towards the future as a mainstream technology. Shabil's Augmented and Virtual Reality Technology Trends Survey indicates 70% of respondents believe the realities will become mainstream within the next 5 years. Rafida Abd Karim from the Harun University in Turkey conducted research that concluded the classroom of the future will be a fully digital environment that supports experiential learning and fosters teaching and learning that closely resembles face-to-face contact. Similarly, Pietro Cipresso and his peers conducted research that concluded the increasing potential of AR and VR within educational industries. This indicates the future integration of AR and VR as a mainstream technology, highlighting its significance towards the industries of the future. As AR and VR continue to develop and expand, their role within the future will become more critical, shaping a more connected and immersive world. Ultimately, AR and VR are being used to provide training and engagement within major industries and will introduce new procedures of automation and computer assistance through its technological development. As these technologies continue to advance, they are reshaping how professionals train, engage, and market products, while also enhancing education by creating interactive and adaptive learning environments. The ongoing development of display technologies such as OLED and the integration of AI and machine learning are crucial in overcoming current limitations and enhancing the immersive experience of AR and VR. Moreover, as the market of AR and VR continue to grow, further investments and industry adoption will support the mainstream acceptance of the technologies. Although AR and VR may have current limitations, the technologies will play a significant role in the future in both industry and everyday life. The technological advancements of AR and VR will establish them as essential tools in our ever-increasing digital world.